So in this lesson today, what we're going to learn about is computer control. We're going to learn about the components that make up a computer system. In particular, we're going to look at sensors. Sensors record analog voltages or analog signals. We're going to look at a computer system which can only understand digital, so we're going to look at analog to digital converters. And we're going to look at the movement that comes out of a computer system called actuators. In addition to this, we're going to look at feedback systems, and we're going to look at data logging systems and the advantages of using computers to log data and the advantages of using robots. So the first thing we're going to look at is we're going to look at sensors. Now, sensors record analog signals. Analog signals are constantly changing. If you try to record the temperature now is going to be not the same temperature as in 2 minutes time or whatever. It's constantly changing. It's going up and down. It's not staying the same. It's the same with light levels. Light levels are constantly going up. They're constantly going down. They're constantly changing. To record them, we use a thing called a sensor. Sensors are used to measure physical qualities or quantities. In the case of the likes of a temperature sensor or a light sensor, these are constantly changing. They're what's known as analog signals. Sensors can record many things. So they can record radiation levels, they could record pressure, they could record oxygen, they could record temperatures, and so on and so forth. They can work in extreme conditions. Again, these are some of the advantages of using a computer. You wouldn't want to record a nuclear radiation level. Again, it would cause you damage. You wouldn't want to record the pressure on the moon. You wouldn't want to record the pressure underwater. Again, these are things that humans find very difficult, and these are things that computers can do very well and very accurately. In order for a computer to understand them, however, there needs to be a bit of processing involved. Computers can only understand digital signals. Computers can only understand what's known as binary, on or off. These are the only things computers can understand, these binary signals here. So in order to be able to read them, they need to be converted into digital signals that the computer can understand. We're going to move on now and look a wee bit about processing. So we've already said that input is done via sensors. So these will be the sensors here. In order for the computer to understand it, it needs to be converted into a form that it can understand. To do this, we use a thing called an ADC. In simple terms, we've got our analog signals here that are recorded via sensors. These need to be converted into digital signals, D. So these need to be converted, and what we're left with is an analog to digital converter. If, however, we want the computer system to give out analog signals, what we would have to do is we would have to convert the digital signals into analog signals. So what we would use is what's known as a digital to analog converter. This is used a lot in the likes of modems, where you're using a telephone line which can only understand analog signals. And if you want the computer to understand it, you need the likes of a modem to convert it into a digital signal. If you want the computer to send signals along the phone line, you need a digital to analog converter to convert it into like a voice that can be transferred over the telephone line. If we move on now, the last part of a computer section is the output. So we've got our input, which is where we've got our sensors. We've got our processing that might be involved, an analog to digital converter or a digital analog converter, or storing the data or deciding what to do with the data. Lastly, we've got our output, and this is in the form of actuators. Actuators control the actual movement. They're things like devices like motors or heaters or robotic arms. So if we look down here, these devices or actuators, the movement does the actual movement. The bulb actually lights up the room, if that makes sense. In addition to that, we're going to look at where the inputs and the outputs are very closely related. If, for example, we look at a greenhouse, we don't want the temperatures going too high, we don't want them going too low. We want to keep them at a constant level. So sometimes if the heat gets too much in the greenhouse, what we need to do is we need to let the heat out. So in a way, the output influences what's input into the system. Okay, so in a feedback system, what we do if the room gets too hot, we'd open up the shutters or open up the exhaust fan to let the heat out. If the room gets too cold, we might put on heaters. This is where the output influences the input. If the temperature falls below a certain level, what we need to do is put on the heaters. If the temperature gets above a certain level, what we need to do is put on the sprinklers, or we need to put on the exhaust fan to get the heat out of the greenhouse. In a second or two, what we're going to look at is we're going to look at data logging. Data logging is recording data over time using sensors. It has a lot of advantages. We'll look at a few of the advantages. The first advantage I will say is data loggers can record information in places humans couldn't. So it can record at the bottom of the sea, it could record inside nuclear reactors. In addition to this, data can be collected over very long or very short periods. If you asked a human to go out and record the rate of a tree growing every month for 40 years, it'd be a very tedious job. The accuracy of the data logging is very important as well. These can record very minute changes that a human eye couldn't actually see. So for example, if you needed to record the temperature every second to the nearest 0.1 degrees Celsius, a human would find it very difficult to read the thermometer that quickly, to see it that accurately, and to record it that accurately. If we look at some terms that you might need to know whenever we're talking about data logging, you'll notice logging interval. This is how often you take readings. So if I wanted to record the tree growing, I might take it every month. That is the logging interval, every month. If I wanted to record the logging accuracy, it's how accurate my readings would be. If I was recording the temperature to the nearest 0.1 degrees Celsius, the accuracy would be 0.1 degrees Celsius. Notice how these things are very accurate, and they can be done over very long or very short periods of time, very accurately. Also, if we're using a computer, these don't need breaks, they don't need pay, they don't need wages, and so on and so forth. These are the main advantages of robots, and they're also the advantages of data logging. So for example, robots could work at the bottom of the sea, they could work inside nuclear reactors, humans couldn't. Robots can record data over a very long period of time or over a very short period of time. Robots are more accurate than humans. They don't suffer from illness or boredom or anything like that. They also don't need breaks or pay or anything like that. And these are some of the advantages of robots.